that, I say good morning. Good morning to you, and welcome to my stream. We are going to be working on, there we go, optimization. Right, so we actually have a fully working locks interpreter now, which is good. And then I had another window here where we were looking at all the tests, and we've got 202 tests passing and 44 tests failing. And I was thinking whether or not I was trying to make a decision whether or not to work on optimization first or work on the bug fixes first, because obviously there's a bunch of things here that we're supposed to be handling. Runtime error operands must be numbers, for example. I see a lot of those. Expected output 4 on line 17. I got 1, got 2, and got 3. That's interesting. That means our closures aren't working. So maybe it would make sense. So what does this output? Expect 4, expect 1, expect 4, expect 2, expect 4, expect 3. What happens if we actually run this over here? I don't know what to call it. Oh, now I have this problem. Okay. Cargo, run, no default features, expect. 112233. Okay, so we obviously have a bug. This is saying var I equals 1, I is less than 4, I equals I plus 1, j is set to I. I don't know what this is doing. But obviously a closure in the body, and then this is supposed to capture the J, and it's not capturing J properly, right? J is supposed to be well, it creates a function each time, right? And if J is 1, F1 is equal to F. J is 2, F2 is equal to F, and else F3 is equal to F. So we're setting these 3 to point to functions that get generated each time. I guess what would I expect this to do? If J is 1, aren't we capturing I? Oh, You know, I don't know. I guess this I is supposed to just refer to this I, so by the time the loop is done, it's always going to be 4. But because we're copying it here, it's going to be the value it was when it was created. Does that make sense? I think that makes sense. So that means that the bug is when we capture the up value. Let's see what the bytecode looks like. It's going to be big, I think. So we have, here's our script. Here's the closure. Yeah, I guess I can't really read what's going on here. We have a function called f, which gets up value 0, prints it, gets up value 1, and prints it. And then when we generate the closure, it should close on local 1 and local 2. Oh, okay. So the variable is definitely variable is definitely a local, right? I is a local, but it's capturing it. It's supposed to capture, and then this is where we actually run the code here. So I don't want to look at that. Get global F1 and then call it and then pop. And when we run it, actually, we do want to see it run. So we have F1, F2, and F3 created there. And then where do we call? Okay, and what do we do here? Oh, then we just loop directly. Okay, that all happens right in line. So here we're creating the closure with the two local variables. Get local 2. Up constant 7, which is 1. If it's equal to 1, then we're going to jump to false. If it's not equal to 1, right, we go to 59, which we don't do. So we go to 47, 50, which pops it, gets local 3, sets global F1, and then pops. Okay, so it's setting F1 to F, but it's not generating a new F, right? This is where it's supposed to create it. Yeah, there's a, oh, okay. So we have a pretty big bug then in locks. Before we can even get to optimization, we need to fix this. Being able to close, and what I'm gonna do is I'm gonna go back over here because we can look at the table of contents this way. Closures. And all of our tests were working. Sorry, all the little tests that were in here were working. It's just that this test, now can we simplify this? Can we simplify this test? I guess would be a good first step. Rather than creating 3 of them, we should just be able to do this. Copy, expect, simple closure locks. We don't need to create 4, right? We should be able to say var I equals 1. No, but see, this is capturing I and j, and then I'm saying F1 equals F, I equals 4. Right? Why wouldn't this just print 1 1, right? Or yeah, because it's printing I, but I was set to 1 here. So isn't it supposed to be capturing that exact value? Let's go here. I guess I don't understand how closures work then, because oh, this is frustrating. I shouldn't have looked. I should not have looked. We're expecting this to be 4. What happens if I run the JLocks version of it? It should work, right? Because we already tested it. Right? If I run JLocks on this. Yeah, so that does the same thing. 4.1, 4.2, 4.3. So that's our other code. And unfortunately, we can't really figure it out based on this because this is completely different. This is done in a completely different way. All right. So, yeah, we need a simpler test. Something that, because this, I think, if I run this using, let's try it. Locks by code, simple closure. If I run this, it does print 4.1. It does print 4.1. If I say j equals 2, here, does it still print 4.1? No, it prints 4.2. But our bytecode version of it, right? Let's try the running the bytecode version. Oh, this prints 4 too. All right, so what's the difference? What's the difference? So I guess we can say I equals I plus 1. Var j equals I. Can we do shadowing in this code? Oh, creating a new variable called var. I guess we have to use k, right? I'm just stretching it out this way and then say this. F underscore 2, and then F2 equals F. And then this should be F2, like this. Right? Isn't that the same thing? And if I say cargo run, two one two one. Oh, because I said print K, print J. Okay. 2122. Okay, so that part's working. It's just that if it's in this for loop here, it doesn't work. What's special about the for loop? We did have some fun stuff around for loops, didn't we? Maybe there's a bug just there. That would make things easier to fix, right? For statement. So here's a var declaration. Stop it. Maybe our up value and our find variable stuff is not working right. Oh boy, this is going to be very, very frustrating until I can figure it out. So I'm going to ignore it and work on optimization then. Because I guess we can just skip forward this way. Methods, classes, optimization. All right, so we'll work on optimization and then we can fix the bug related to whatever this is doing wrong. Expected runtime error, undefined variable method, and got undefined variable method. Oh, without the quotes. Okay, that's easy to fix. All right, let's do this, and then I'll go back and start looking at the other ones, the other bugs, and then we'll be done. All right, optimization. If I still lived in New Orleans or Nolans, and it's been a while since I've been there. I'd call this chapter a lagniappe, a little something extra given for free to a customer. You've got a whole book and a complete virtual machine already, but I want you to have some more fun hacking on C-locks. This time we're going for pure performance. We'll apply two very different optimizations to our virtual machine. In the process, you'll get a feel for measuring and improving the performance of language implementation, or any program really. Okay, measuring performance. Optimization means taking a working application and improving its performance. An optimized program does the same thing, it just takes less resources to do so. The resource we usually think of when optimizing is runtime speed, but it can also be important to reduce memory usage, startup time, persistent storage size, or network bandwidth. All physical resources have some cost, even if the cost is mostly in wasted human time, so optimization work often pays off. There was a time in the early days of computing that a skilled programmer could hold the entire hardware architecture and compiler pipeline in their head and understand a program's performance just by thinking real hard. Those days are long gone, separated from the present by microcode, cache lines, branch prediction, deep compiler pipelines, mammoth instruction sets. We like to pretend C is a low-level language, but the stack of technology between printf hello world and a greeting appearing on screen is now perilously tall. Optimization today is an empirical science. Our program is a border collie sprinting through the hardware's obstacle course. If we wanted to reach the end faster, we can't just sit and ruminate on canine physiology until enlightenment strikes. Instead, we need to observe her performance, see where she stumbles, and then find faster paths for her to take. Much like agility training is particular to one dog and one obstacle course, we can't assume that our virtual machine optimizations will make all locks program run faster on all hardware. Different locks programs stress different areas of the VM, and different architectures have their own strengths and weaknesses. So when we add new functionality, we validate correctness by writing tests. Locks program that use a feature and validate VM's behavior. Tests pin down semantics, ensure we don't break existing features when we add new ones. How do we validate that optimization does improve performance and by how much? How do we ensure that other related changes don't regress performance? Oh boy, are we going to get to any coding at some point? Okay. Locks programs we write to accomplish these goals are called benchmarks. These are carefully crafted programs that stress some part of the language implementation. They measure not what the program does, but how long it takes to do it. Right. So we did some benchmarking before. Right. We were measuring the fib. We measured the init call. It was released, right? Default features, init call, and that measures how long it. Oops. Yeah, that's how long it takes to like a million init calls. It's 3,500. But once you have an entire suite of benchmarks, you can measure not just that and optimization changes performance, but on what kinds of code. Often you'll find that some benchmarks get faster while others get slower. Then you have to make hard decisions about what kind of code your language implementation optimizes for. The suite of benchmarks you choose to write is a key part of that decision. All right. Benchmarking is a subtle art. Like tests, you need to balance not overfitting to your implementation while ensuring the benchmark does actually tickle the code paths you care about. All right, so now you've got a few benchmarks. You want to make them go faster. Now what? Hardware is too complex to reason about our program's performance from first principles. We have to go out into the field. That means profiling. A profiler, if you've never used one, is a tool that runs your program and tracks hardware resource use as the code executes. Sophisticated ones log data cache misses, instruction cache misses, branch miss predictions, memory allocations, and all sorts of other metrics. There are many profilers out there for various operating systems and languages. On whatever platform you program, it's worth getting familiar with a decent profiler. You don't need to be a master. I've learned things within minutes of throwing a program at a profile that would have taken me days to discover on my own through trial and error. All right. The tiniest possible change we can make to our VM. So this is faster hash table probing. When I first got the bytecode virtual machine that CLOX is descended from working, I did what any self-respecting VM hacker would do. I cobbled together a couple of benchmarks, fired up a profiler, and ran those scripts through my interpreter. In a dynamically typed language like LOX, a large fraction of user code is field accesses and method calls. All right, well, I mean, we can run this. Yeah, no default feature is due. Yeah, this is gonna take us forever because this is 100 million. If you've never seen a benchmark before, this might seem ludicrous. What's going on here? The program doesn't intend to do anything useful. What it does do is call a bunch of methods and access a bunch of fields, since those are the parts of the language we're interested in. Fields and methods live in hash tables, so it takes care to populate at least a few interesting keys in those tables. That's all wrapped up in a big loop to ensure our profiler has enough execution time to dig in and see where the cycles are going. Before I tell you what my profiler showed me, spend a minute taking a few guesses. Where in CLOX's codebase do you think the VM spent most of its time? And I'm going to guess it's hash table lookups. The function with the greatest inclusive time is run. Oh yeah, so I don't have a profiler here for Rust. Rust profile. Instruments, yeah, we might have that. Oh, hello, Ravi. Sorry, I missed you. Mix the Pick is a low-level programming language. It's considered a low-level programming language, yeah. Heap track and bytehound are heap profiling tools. Causes casual program. To profile a Reese build effectively, you might need to enable source line debug info. All right, but it doesn't say how to run. Not according to the ACM. What is the ACM telling me? C is not a low-level language, right? Okay. When was this published? July of 2018. Fair enough. It's not. Maybe it's not low enough anymore. Maybe there've been new levels added below it. Because I don't think C has changed all that much. Yeah, right. No, I get this. You know, it was based on the PDP-11 architecture, whereas it was designed for writing an operating system on the PDP-11, and it sort of grew out of that. It's low level in the sense that you can generally translate the concepts directly to machine code, but I'm sure there are lots of, like I said, lots of levels now in between the layers that prevent it from being as low as you think it is. But I'll read that. I'll read that article. It does seem like an interesting article. Perf is perf. Is that a Linux tool? Yeah. Well, there's no perf here. And I don't want to brew install things on stream. Okay. But instruments is here, right? This is a Mac. And I don't know how to use instruments. But it would be nice to be able to choose a profiling template for all processes. Blank trace document can be customized with instruments from the library. All right, well. Brew install on stream. What could possibly go wrong, says Mix the Pick. Right. But let's see what they say here. So if you take a look at table get, you'll see mostly wrapper around a call to find entry where the actual hash table lookup happens. This is all a find entry. When running a previous benchmark, on my machine at least, the VM spent 70% of the total execution time on one line in this function. But it's this. The pointer dereference isn't the problem, it's the mod. Right. Turns a mod operator is really slow, much slower than other arithmetic operators. So this isn't something that we can do here or we need to do, because we're running, we're just using the hash table. Where would that be even? VM? Yeah. Hash map. We're using the hash map code that comes with the Rust standard library, so there's nothing to do there. Right, this is talking about how to improve that speed. Okay. Modulo is 3000 and bitmask is 60. It's about 2 times faster, right? NAND boxing. This next optimization is a very different feel. Thankfully, despite the odd name, it does not involve punching your grandmother. It's different, but not like that different. With our previous optimization, the profiler told us where the problem was. We merely had to use some ingenuity to come up with a solution. This optimization is more subtle, and its performance effects more scattered across the virtual machine. Speaking of NAND, what happens when we do that? Cargo run, print 4 divided by 0. It just returns with inf. I don't think that's something I did. I think that's something because it's just a number. It's an F64 that we're dividing. So we're getting inf out of divide by 0 here. This operation is called NAND boxing or sometimes NAND tagging. Oh, I see what they're doing. I see what they're doing. They're saying, oh, the value takes up 16 bytes. But you can if you stick the 64 bits into right, there's a whole bunch of different NAND numbers in floating points. Right, so you can actually steal some bits here to indicate that, okay, this is not a floating point number, this is actually an integer or a Boolean or something. Right. 64-bit double has enough room to store all the various different numeric floating point values and also has another room for another 51 bits of data that we can use however we want. Right. So we have these 50 bits plus this 1 bit. If all of these are 1s, this bit is set to quiet and that's set to 1, then we can use the other 51 bits for whatever we want, including nil, true, and false. We can stuff 48-bit pointers in our 51 bits, right? And not worry about, okay, so that's obviously not something we need to do in Rust, because I'm just using this value thing. And actually, you know, now that I've done all of this work, it's clear that this is not the best way to do it in Rust. There are better approaches that we could have taken, but this is like a Rust port of a C code. So I think unfortunately this last chapter is not going to help us at all for. Yeah, I'm just scanning. What else we got? Evaluating performance. Yeah, so one of the things that would be interesting to do is learn how to use instruments. Where's my instruments? Wait. Oh. The window's gone. I guess I have to say new, right? This creates a new instrument, and then maybe I can learn this off screen and figure out where we can counters are. Collect performance, monitor events using time or event-based sampling methods. Time profiler. That might be interesting, but maybe not on stream. I got to learn how to use it off stream, and then I can come on stream and demo it. All right, so we're not going to do optimization. What we're going to do instead is fix all the bugs that we can fix, and then I think there's some that I'll have to investigate later. But I think some of the easy ones we should be able to fix. This one's a hard one. Obviously, there's a bug in my closure code. So let's go over to locks bytecode and start fixing some of these. Should we start at the bottom? Undefined property init. So let's take a look at this test. Expect init, expect foo instance. And what happens if I run it? Cargo run, crafting interpreters, that. Undefined property init. But Oh, that's right. We did it. That's right. Git log. What I did was I did attempt to make init calls faster, and then that broke using init this way. If I say cargo run, we should at least see the first init, and we do. Okay, so let's fix that bug that I introduced for init. Because what I did was I changed the class to have a separate init thing, so we wouldn't have to look it up in the hash map. And that was the idea, was it would make things faster by not having to do a hash map lookup. And we have a get init method, set init method. In get method, we should say if name equals init, then we're going to say we'll just get init method. Else this. And I think that'll fix that bug. Right? Yeah, init foo instance. Okay, so that fixes that bug. This looks like it's the same bug. Okay, expected runtime error operands must be numbers and got operands must be 2 numbers or 2 strings. Oh, hello. Oh, I don't know how to pronounce your name. I'll call you Highway until you tell me otherwise. Asking out of curiosity, are you comfortable using Vim without line numbers? Yeah, very comfortable using Vim without line numbers. I've never had the need to see line numbers on there. I guess I could try it and see what it looks like and see how it would change my workflow, but I've never really needed. I mean, if I need to go to a specific line number, I just do it, right? Right. If I wanted to go to line 200, I just say 200, and there I am. I don't need to know what line number these are in order to see what the code does. So I don't know. Maybe I'll turn it on one day and see that it revolutionizes my editing experience. But until then, must be 2 numbers or 2 strings. Okay, so we have a bug here where we're expecting operands must be numbers, and I have just 2 numbers or 2 strings. Highwise says, I like having relative numbers for easier jumping. Oh, yeah. Yeah, I guess if you have the relative number display up there, you can say, oh, that's 5 lines up, so I just say 5K and go 5 lines up. Yeah, maybe. Okay, so there's a bug here in binary op. We need to be able to say operands must be numbers, and I guess we don't know what binary op this is. Oh, it's a greater or equal num non-num. So that's true. It should be. It shouldn't be the 2 numbers or 2 strings thing. It's just that they have to be 2 numbers. We can't do 2 strings with the greater than or equal to. So we're checking here if they're 2 strings, and we're checking here if they're 2 numbers. I guess the operator needs to say whether or not. Where do we call binary op? Here. Oh, for greater and less, we just do it directly. We assume that they're numbers. Okay, so I wonder what we can do. We can actually pass in the valid operand types, right? Right, we can just say operands to num, or we could say, yeah, greater has to be 2 numbers. We could do that for less. Oops, right there. For add, can be 2 numbers or 2 strings. Right? And then for subtraction, it has to be 2 numbers. Oh, I didn't want to do that. I want to do this. Okay. Copy that. Paste that there. Oops, I copied too much. No. Paste that there, there, and there. We also need it here, right? Oh, we're not even checking here. We're just saying not falsy. Okay. And negation has to be a number, so we check there. All right, so then down here in binary op, we'll take that operand, op type, operands, and then we'll have to check the op type. So this works. So I guess it's just for the error reporting. If match, I guess match op type. No, because we're doing this or. We'll just say numbers or strings. Okay, so then we can just say match op type, operands to numbers, and this, I guess this is debugging output we had, and this should be the operands of two numbers, and then oops, yeah, operands numbers or strings does that, and then this must be numbers. Right, and that ends that match. We'll put a comma there, and that should do that. And now we have to create this operands type. Where's our first enum? We don't have any enums in here? Okay. I guess we'll just throw it at the top. Enum operands. Right? Two numbers or strings. All right, so hopefully that fixes those. Let's find out. It was, oh, we gotta go all the way back here. That's annoying. Operands must be numbers. Okay, so that's good. So let's rerun these tests. Where's my tests? There it is. We have to build it. Cargo, build, release. Let's see if we get any better than last time. Whoa. Okay, that's not good. So I broke something. That was probably the fix to the init thing I broke. Right? Let's undo that change. Class? Yeah, this should have worked. I don't see what would have. Let's just put this here, comment this out for now. And see if that fixes that problem. Oh, I forgot the no default features. That was it. Not, okay. Class. It was the no default features thing that was the problem. Okay, so let's try this again. So now we only have 20 tests failing. I forget how many there were last time, but it's fewer. Expected true on line 10 and got false. So this is equals method. Nope, a cargo run. I meant to do cargo run. False, false. So let's take a look at it. And what is it doing? Bound methods have identity equality. Oh, that's right. We're just... I think we just have false for bound methods. For partial EQ. Yeah. So we can fix that. Let's see if that works. True, false. Okay, so that fixed that one. Now we have too many parameters. Unexpected error. Error at A can't have more than 255. Missing expected error. Error at A can't have more than 255 parameters. Oh, I misspelled parameters. Okay. That's easy enough to fix. RG that. METERS. There we go. So that fixes that one. Expected runtime error, undefined variable method. Oh, method has to be in quotes. That's probably in VM, right? Variable method. No. Okay. RG variable method. What am I doing wrong here? This is what we got.
I don't know what y'all think, but I think that's pretty.
Yeah. Oh, it gets put together. That's right. So let's look for undefined variable. So there's two of them, and one of them is missing the double quotes. So, yeah, there we go. 305. Like that. Or a single quotes. Expected. Okay, so that should fix that one as well. This one we have to figure out there's a bug in our closures. And then we have test for scope. Oh, we have a problem with our for scope. So maybe that's related to the closure bug. Let's take a look at what that is. Crafting interpreters, test for scope. And we're getting error at I already available with this name in this scope. And it shouldn't, right? Because this var I should be in an inner scope. Right. So we have a problem doing variable lookup, and yeah, like I said, maybe that's related to the way this is doing this closure bug. So okay, let's see if we could figure this out. So in our for loop code, the for statement is kind of odd. We do have a begin scope right here. That was the first thing I was thinking. Well, let's look for that. Let's look for scope issues. Jumping back and forth. Maybe it's in here. Yeah, for statements. All right. Yeah. So this got built up out of from while code, right? While loop code. So this is going to be a little awkward to try to go through. But we do have a begin scope here. And there should be an end scope right there. So it could be that I have the begin scope in the wrong spot. No, because we got the for, we begin a new scope, and then we have this. So where is it finding, right? If I say cargo run, with this instead. Whoa. I guess I was looking at the wrong... Oh! I put compiler.rs instead of this thing. Okay. Yeah. So we're seeing already a variable with this name in the scope. So already a variable with this name in the scope. Find result depth. Oh, maybe this is the bug here. We're finding the variable at the wrong... Okay, let's see. I've forgotten what find results options are. Oh, maybe depth is 0. So let's put a D here, and now let me put a D here, because a depth of 0 should be okay, right? If we're... I mean, yeah, a depth of more than 1 just means we're going to shadow it. That might be the bug. All right, let's find out. Run that. Oh, oops. This should be format. Okay. Okay, let's try again. Yeah, this is saying depth 1, which means we should be able to do a... Maybe that's the bug. Okay, let's... that was an old one. So, I guess we just want to see if 0, right? And then we can get rid of this, and this, and now we have a bug with our closing. There we go. Okay, let's try running that again. And hopefully that's what they're expecting. Expect 0, expect -1, expect after, and expect 0. Okay, and let's just test the closure one now. Maybe that works now. Maybe that was the bug. That would be nice because I was kind of at a loss for that. No, that doesn't fix that. Okay, dang it. All right, so constructor. Expected 0 arguments but got 1. Let's take a look at that one. Oh, let's cat it. Class A init param. B value, because B inherits from A. Oh, when we inherit, I forgot that we also need to inherit the init function. That's a problem, right? Because we set the init method, we copy all the methods over, but we also have to copy the init over as well. Katak Biru, thank you for the follow. Very nice of you. Katak Biru asks, what are you making? Show me. Okay, I'm making this crafting interpreters thing. Let me paste the URL for this into chat, and then you can take a look at what I'm working on. But basically what I'm working on is trying to fix all the bugs in my version of locks based on all these unit tests that were on the crafting interpreters website or GitHub. All right, so what we need to do is where we copy the method names. Where do we copy the method? Is there an inherit? There is. Here we go, subclass copy methods. So when we call copy methods, we also have to copy over the init. Self init dot borrow mute. Replace with self superclass init, and then it's going to be a clone. Some RC clone superclass init. Nope. Is that all I have to do, or do I have to ampersand that? Oh, found ref cell, so I can say borrow. Nope. Oh, okay, so I can say if let some init func equals superclass init borrow as ref, like that, then self init replace with yeah. Actually, we don't even need to care because it could be a none, right? So we do this. Superclass. Right, what does superclass return? Get init method returns option RC closure, which is exactly what we need. Get init method. And it doesn't like that because I have 2 dots. And it doesn't like that because I forgot a semicolon. And it likes that. Can I tell you what it does? It is an interpreter. So it, for the LOX language, we have a bunch. Let me show you what LOX looks like. If I look at refer to name, take a look at that. It's just a simple little language. You can define classes on it and have print commands and methods and all that kind of stuff. It's just a very simple, straightforward language that allows you to learn how to make an interpreter. I don't want to say it's a toy language, but it doesn't have all the features that you would need for like a workhorse language, right? But that's all this is doing is running these various. Let me demonstrate here. We have a whole bunch of test code that I've copied and pasted over the course of the streams that I've been doing. So like this, just says a for loop, cargo run. And this should just print out 0 to 4, right? And it does 1, 2, 3, 4, 0, 1, 2, 3, 4. So that's all this is doing is this code is scanning this file, converting it into tokens, parsing the tokens, turning it into bytecode, and executing the bytecode. And you can see what the bytecode looks like up here. I gotta double check my chat filters because I'm still getting all of those spammers in chat. All right. So let's see. I think that we fixed that bug. Oh, and then we just should have fixed the init method with this thing. So let's rebuild here. So because we fixed a bunch of issues, and let's take a look at our most recent result. We had 226 passing and 20 failing. Now 236 passing and 10 failing. This one is going to be a toughie. Okay. Unexpected error. Error at VFF. Too many closure variables in function. Oh, did I miscount? Maybe I'm off by 1 here with this. Too many up values. What does this look like? So it shouldn't fail here. It should fail here. This is what it's saying. So let's RG closure variables. So obviously we're checking at the wrong points. If time result too many variables. Okay, so where is that being defined? Up value count is equal to 255. Okay, so we should save if it's greater than. Now we have a warning saying it can't be, because up value count is a U8. So we can never actually check that. We can put the 255th one in there. So I guess what I can do is this, right? I can get the len and say if it's greater than 255, then too many variables. And then we have to use up value count as U8. Right, because it won't get past here unless a value count can fit in a U8. Okay, so maybe that'll fix that one. Missing expected error at arg, already variable with his name in the scope. Oh, didn't we already just fix that? Okay, let's take a look. Oh, missing expected error at arg. Okay. So it looks like we were allowing 2 arguments with the same name. Arg, error at arg, already variable with this name in the scope. So where is that? That's in the compiler, right? Argument list. Yeah, look at that. We're just... Oh, this is the argument list, not the function function. Okay, so now we loop. We look at the arity, define a variable if self is matched. Okay, so we're not checking here. Did I miss this line when we were doing this part of the code? Maybe. Where's functions? Calls and functions. Function declarations. I guess we have fun declaration, right? So this is doing all of that. And then we have this function right there. Stack of compilers. Function parameters. Right? So where are we checking? Right, this is putting the arguments together for a function call. That's implementing call, resetting the frame. That's the call frame. Runtime error checking. Here we go. This is probably what I missed. Expected %d arguments but got d. So that's... Oh no, this is a compile time. This is a compile time error checking. So I don't think that this code... Returning from functions. Return statements. Native functions. Yeah, I don't think he has code in the book for this, unless I'm missing. I'm just scanning over this thing too hard. Define variable. What does that return? It doesn't return anything. So how do we know if we have a variable with this name in the scope? Duplicate local should have the same issue. Let's find out. So maybe there's a higher level bug going on here. Error at A, already a variable with this name in the scope, and we're not seeing that. Cargo run. Var A equals 12. Var A equals 12. Yeah, it just lets you do it. What if I do this? Var A equals 12, var A equals 12. Yeah. Huh. So there's something weird, right? This should be, I thought we caught these. All right, so let's go up. And maybe in global variables. That's it. Local variables. I'm just looking to see where we, yeah. So identifiers equal name, local name. Okay. So this is in declare variable. So that's actually something that happens, right? Source VM. Something that happens in our, oops, I'm looking for a compiler. Yeah, so define variable happens, but where does declare happen for these guys? Right, isn't it split into a define and a declare? Isn't that how it works? That's what we were doing before. define declare variable. Oh, maybe this is what broke that. If I change this here back to what it was, right? And cargo run now. No, so that wasn't. So that didn't break it. That was a correct fix. Right. And this is how we translated the Rust code, the C code into Rust. We're calling this find variable thing. Let's take a look at find variable. But we're not calling declare variable, right? In the function thing. Function declarations, right? Where is that? Here's the open brace. Yeah, so here we're calling define variable, not declare variable. And define variable, does that check to see? Or is that supposed to check? Because right now it's not doing anything error checking wise. Define variable. Yeah, so there's nothing new there. Let's go here. That's define variable. It just says define global. That's the only thing it does on that chapter. In local variables, we have defined variables. Current scope depth is greater than 0, so that's what I did here. Oh, sort of. Then we mark initialize. So that's what I have here. Right? If it's not in scope, then we emit a global. If it is in scope, we mark it as initialized. Okay. That's all that does. Jumping back and forth. There's no changes there. And here's calls and functions, and it's just doing it. We're calling it, but we're not changing it. And let's take a look here. It's not in closures, garbage collection. We use it in class declaration. That's it for that. Superclasses, define variable 0. And then optimization, which doesn't have it. So, how is this duplicate parameter supposed to work? I guess we could just add code directly in here just to see if you have multiple. Because what happens? What kind of bytecode gets generated if we do this? Let's cargo run, and we just make that function, right? Fun foo arg arg, like that. Foo doesn't do anything, but it still has. So we have defined global foo. We don't actually put the arguments anywhere, do we? Foo 1 2. What happens with this? Up constant 1, up constant 2, call, pop. Yeah. So get global foo. We grab a constant and we call it, and it just returns nil. So how does it? Where is it defining the argument names? You know, I went through this whole compiler thing You think I'd know, or an interpreter thing, you think I'd know how to get this. Self parse variable. Maybe it's in here. Yeah, declare variable. Oh, but this doesn't return anything, right? Yeah. Oh, it does return an error. Here, it sets the error if it finds it already. Okay, so maybe that's the way it's supposed to work. Println trying to declare name. Right? And let's see what it says when I run this. Fun, foo, arg, arg. Trying to declare arg, trying to declare arg. So it's supposed to find it here and say, oh, there's already a variable in the scope. But it's not finding it. I wonder what is it getting back here? Harris Heller is fire. This is from Spring Rollin'. Or it was. Oops, it just ended. Okay, so I think the bug must be here and that we're not finding the variable in current scope. And it should be because we've declared it already. Add local here. Can I do this? Println debug of self result borrow find variable name. Can I do that? Togglebit, thank you for the raid. Hello, Diablo. Find result can't be formatted. That's easy to fix. Find results. Just add a derived debug. Rod, thank you for the follow. And Dante Chilas, sorry, I don't know how to pronounce that. Thank you for the follow as well. And Mandragora, thank you for the follow. And Evan Coates, thank you for the follow. Mandragora, that's from Doctor Who. Sissel Veg Unit, thank you for the follow. I get lots of follows when Togglebit raids me. And, I can't pronounce that. Fidekuk, thank you for the follow. Diablo says, so how's the interpreter thing going? It's going poorly. I'm debugging all the bugs I put in when I didn't translate things into Rust correctly. So that's what we're working on now, is fixing all these things, all these issues. Yeah, so if I got a not found, which means it was fine, and then it found a depth of 1. Interesting. Maybe that's the correct depth error. Douglas Ballack, thank you for the follow. Oh, Fernando, sorry. I don't know. For some reason I can't pronounce Fdaciuk as Fernando, but I will endeavor to remember that. Diablo says you can't debug until you insert the bugs. Yep, that's true. So I got all the bugs there, and now I'm trying to get them all back out. All right. Let us figure out, maybe depth 1 is correct, but we fixed the other bug with depth 0. So obviously there's some other issue going on here. Maybe depth 1 is the correct fix for that. Let's get rid of this println, and then I'm going to try rerunning these tests. This project is crafting interpreters and porting crafting interpreters to Rust. Let me just throw this in chat real quick. Oops, I put 2 slashes on that. Yeah, we have 10 tests failing, and I think I must have broken something else with that depth 1 thing. Because we had 10 tests failing last time too. Oh, I didn't build it. That's the problem. That's why. Let me build it. Okay, so now we're down to 9 tests failing. We're getting better. And what I'm doing is actually crafting interpreters is written in both C and in Java. There's 2 different versions: a tree walk interpreter in Java and a bytecode version written in C for this LOX language. And I already have. Oh, that's the kilo thing. Somewhere I have my GitHub. So this is the LOX bytecode GitHub, and then I have a repo, and the LOX AST is over here. So this one's done, and all the tests pass on that one. So I'm just trying to get the tests to pass on the CLOX version of it. All right, shadow and local. Let's take a look at that test. Var outer, print A, expect outer, var A equals inner, expect inner. So we're seeing a bug in that cargo run. If I try to run it, it should print outer, inner, but we're seeing this error here because the depth, or we have a problem with our depth perception. Depth of 1. So if I change this to 0 and run, and now it correctly works. We see outer and we see inner. So I think depth of 0 is the correct answer here, but it's just that when we're in a function, in the function declarations, we don't have the scope yet. I think that's the problem. We don't have we didn't do a begin scope or something. Function. Yeah, we have a begin. Oops. Yeah. Okay. Let's go here. We have a begin scope here, which should give us our new scope for these variables. But for some reason, when we define the first arg. I mean, we saw it up here, right? Not found first. First one was not found. Oh, maybe that was the foo here. This arg. Okay, now I'm confused. Let's take a look at these variables here. Constant is parsed variable. Oh, we don't get the name. Oh, okay. We're going to define variable constant. And this is just going to be a number. So we got to figure out what this is. Oops. I just want to do cargo run because I want to run this fun foo arg and take a look. Yes, define variable 0. It's getting constant 0 both times. Oh, I wonder if it's just looking it up. Parse variable is just returning nope, there it is. It calls declare variable and then checks after parsing the identifier. Right, okay. So in declare variable, we've got to trace this all down here. If it's in scope, so if we're in a scope, sorry, then we get the name of the variable. Right, and then we look it up. And we can just say adding local. right? Black Udon says, you done find the consequences of your code. You're right. If I hadn't written any code, I would have 0 bugs. I agree. Okay, so we declare variable arg, adding as local, define variable 0. Declare variable arg, adding as local. So it's seeing it as a local again, because the depth is returning as 1, I think, for some reason. Let me just print this out here before we do any work. We can say println find result is equal to this. Oops, I missed the this thing here. Like Udon says, the most perfect code is 0 code. I agree. Okay, declaring the variable arg, find result is not found, adding as local. So it defines it as variable 0. We declared the second variable arg. The find result is showing a depth of 1 now. So it's saying that there's an arg in the previous scope and not in the current scope. And that's why it's adding it as local again. What happens if I say find bar arg? It's going to create a new depth for each one? Yeah, it is. Why is it doing that? Black Udon says, I cannot imagine a tool that works with no code. Or any tool that works with no code. Well, I mean, here we go. I'm using NeoVim with no code. What am I doing really? Compiler. So I think it looks like we're creating a new depth, new scope for each argument. Is that true? I don't see where the new scopes are coming from. This begin scope is outside of the loop. Is there a bug in the find variable code? No. Self locals borrow iter reverse enumerate. So what is locals? Locals is it's just a vec of locals. Oh, maybe this is the bug. We're not supposed to be looking backwards in that array. We're supposed to be looking backwards in... I mean, the depth is not supposed to be... I think this is the bug. The depth is how many levels back you have to go. To resolve the local. That's right, we have to go up 1 each time. Broken Rabbit, thank you for the follow. All right, do we have to, when we do a find variable, we don't want to walk our way backwards in the current locals. We actually want to look at the variables that are above us. So it's not this. This is the wrong calculation to do. Ah, okay. So, v depth is none. We're setting the depth. What does that define? That's the depth of the current value. So I bet you, oops, find variable. Yeah, if there's no depth and we do that, are we supposed to just return the depth here? Maybe that's what it is. That doesn't seem right either. I'd have to look at this chapter again to find out what's going on. And now we have warning that we're not using E. That's okay. Let me just see what this does while the train goes by in the background there. But these should be depth zeros, not depth ones. And it's still not saying, it's still not telling us that we have a predefined. Oops. Compiler. Come on. There we go. I'm getting too antsy right now trying to figure this out. Okay. Let's restore this. And then we can take a look at the code here where we actually try. Oops. I don't need to go up. Where did we do this find resolve up value? No. Jumping back and forth, calls and functions, closures. Yeah, so this is where we did resolve up value. And resolve up value is the thing that goes and looks at the closure to see how far up the stack we need to find the value. We keep going up. Where is this doing? This is saying self-enclosing bar as ref resolve local. So right, so if the scope above us can resolve it, we'll get that as the value of how far up we need to go, or we'll get a find result saying it's didn't work. Yeah. So this find result depth returns us the depth we need for resolve local. But it's calling find variable, and find variable just needs to return the current. Yeah, it has to return the current depth plus whatever we're doing. All right. So let's take a look at this. Compiler enclosing is null. Return -1. This is saying if enclosing is not null, then we're going to call resolve local. This is saying unwrap capture. Okay. And then add up value is here. So this is the resolve local side, right? We're doing a resolve local. If it works, then we're going to add the up value. This does the capture business, which we haven't gotten to at this point yet, but we did get to it here. And then we also have, yeah, here's add up value. So I guess tracking the depth is a little too tricky. Black Udon says maybe Squarespace can build something with no code. I've heard of Squarespace. I've never played with. Oh, it's a website builder. Okay. Yeah. It's all templates, but underneath it is all code, right? Add up value. And then we have. Right. So this is actually returning how many up values you have. And that's where this comes from, is resolving up value returns the index that you find at a given depth. So we already have the depth here. Where's the depth coming from? It's not here. It's coming from, it's coming from here, which is resolve local. Resolve local returns the depth that find variable returns. And find variable is returning how far back. And so this shouldn't be doing on locals, right? This should be popping up the enclosings. And I don't think we have find variable. I don't think that's I think that was something I invented. Yeah. So if we look straight from global variables, yeah, and local variables. I did, yeah. So I created this in order to handle this whole resolution thing, to make it easier. All right, so that's something I'll have to look on. Neochrome says, in my opinion, no-code solutions will only get more and more popular. No one wants to learn CSS, and I can't fault anyone. Yeah, I mean, obviously, yeah, I think that if you have tools that make it more accessible for people to create things, it's going to be less and less code involved. And what you give up is flexibility, but what you gain is speed, I guess, speed of development, right? So you trade off some flexibility for speed. I think that's reasonable. Like Udon says, companies that want that one button on a page to highlight with a tooltip that pops up to the left instead of to the right would want someone to know CSS. Yeah, or they go to their site builder vendor and say, hey, give me this feature. Right? All right, so I'm not getting anywhere with this right now, but I'll have to take a look at it later. What did I change? Oh, yeah, I just put that back. Okay. All right, so is there anything else we can do, fix really quickly before I go? Error at equals, expect semicolon after expression. Okay, let's take a look at this test. Maybe I can fix that one, and then I'll take a look at the other ones later. Oh, error at equals invalid assignment target. Error at equals expect semicolon after expression. That's an interesting one. Right. I guess it's this one here, this line, 1019. Right? So we get an expression statement, we see an expression, and then we try to consume a semicolon. This is saying that we should be parsing the, right, so it looks like this, a equals value. So we see an open paren, so it's an expression statement, and then we close the paren, and then we see an equal sign. And that's when we generate this error at equals, expect semicolon after expression. And this is saying it should say invalid assignment target. So there should be something here in expression statement that checks to see if it's an equal sign and report that error. Right? Oh, Dodo to Centrale Paris. Thank you for the follow. So, right, where do we do expression statements? Here's local variables. We don't care about those. Statements. Assignment. So we do allow expressions to be there. So we should have an expression statement that actually lets us have an expression to the left. It's just that this is not a valid expression statement. Whereas if I said, you know, foo dot bar of whatever dot baz equals value, that's valid. Right? So we need to be able to allow this while disallowing this. So maybe there's a bug with this issue, this thing here, because we went through expression, right? Expression is just parse precedence. So there might be something here where we have a less than or equal, where it should be a less than, or something like that. Because this is what we're supposed to be seeing, right? Invalid assignment target. Or maybe the can assign didn't make it all the way through correctly. Can assign is equal to precedence is less than or equal to assignment. All right, so let's print that out. Println can assign. Let's do it like that. And I should be able to just cargo run and take a look at it. Can assign is set to true twice. I guess we need to figure out why. Because the precedent, let's print out the precedence. Precedence. Doesn't like that because it's not formatted with default. Okay, precedence. That should be easy enough to, hello. Jump to definition is not working. Oh, there it is. It's right there. Debug. Nope. Oh, debug. There. I didn't want to implement display for that, right? It is assignment, so it is settable. So maybe that's the bug. Some prefix rule. Oh, we're passing the precedence in here. Oh, no, it was in expression, right? And we are passing in precedence assignment. So parse precedence. Where is, yeah, so here's the can assign, right? This is this line here, right here. And then we have the prefix rule. So I think maybe, is there a bug in the way we handle it in expression? No, now we're back to the beginning again. In expression. Nope. Okay, so let's take a look at compiling expressions. Oh, but we don't have the precedence thing here, right? Expression, open paren. So what goes here? Expression and then consume right. So where is our expression? Yeah, it changed to parse precedence. So we have to take a look at the next part of the code that does this. Parse precedence, precedence assignment. That's it. So that's what we did here. And is that it for the expression? Because if we do an open paren, right? Let's see. It's not there. Not there. Not there. Not. Oh, it is there. Oh, after expression. Okay. There are 12 of them. So print statement is this. Expression statement is an expression. But that's what we're doing, right? We're dealing with an expression statement. We should be able to say, no, you can't. can assign a match token equal. So I think that's already in named variable, right? Yeah. Okay. Yeah. So that's there. That works. We have grouping, calls expression, and then we're back to the beginning. So it didn't... Yeah, it's just those two. There's a call to expression in each one of those places. That makes sense. And that's, yep, that all makes sense. There's argument list or expressions. Lobsang, thank you for the follow. Return statements have expressions. Yep, that all makes sense. Enclosures, we don't do anything with expressions. Garbage collection, we don't. Class and instances. Right, so the dot can do an expression. And remember, expression is just a call to parse precedence. Methods and initializers. Superclasses doesn't have anything, and then optimization. Okay, so looks like we're doing the right thing, but not. I mean, looks like we're doing what the code says, but we're not checking this. So this might be another instance of maybe there's something missing from the book, or maybe there's just something I just don't understand. All right, with that, we do have a bunch of changes that fix a bunch of bugs. We're down to 9 failing tests, right? Let's just double check. I didn't break anything. Oh, I probably still have some print statements in there, right? That I want to get rid of. Yeah, this one here. And this one here. Okay. Don't want that. Don't want these guys. Don't want that. Or that. That's an error message. That's fine. Okay. So let's build this again. We'll try this again here. DNA 44, thank you for the follow. Okay, so we have 9 tests failing, but we fixed a bunch of them. When we started, there were a lot more. So git add source, git commit -m, fixed a bunch of test suite errors, bugs. Okay. And then tomorrow I'm going to see if I can finish the editor. Syntax highlight. Oh, not tomorrow. Tomorrow I can't stream. Friday. Friday we'll do syntax highlight. All right, that'll be that. Meanwhile, I'm going to end the stream here. Who can we raid? Is anybody having fun out there with Rust? I don't see any Rust out there. That's a shame. All right. I don't have any other suggestions unless somebody has some ideas of who I can raid. Let's just call this a stream, and we'll finish it up there. Let's actually. Oh, Jackie Codes is on. So let's go raid Jackie Codes. And I will see you Friday. I can't stream tomorrow, but I can stream Friday. So have a great rest of your day. Have a great tomorrow, and I'll see you then. Take care.